Today, we will be exploring the idea of how we breathe by taking a closer look into the respiratory system. Its primary role is to extract oxygen from the air when we inhale and dispose of carbon dioxide in the body as we exhale. The respiratory system becomes critical for those that participate in athletics, but it's also essential for us in our everyday lives. On average, we breathe in about 11,000 liters of air a day, and the surface area of our lungs is about the size of a tennis court. Let's go ahead and take a closer look at the respiratory system and its many components. As you breathe, air enters the body through either the nasal cavity or the mouth. It then passes through the pharynx and continues to the trachea. The trachea is composed of fibroelastic connective tissue and hyaline cartilage arranged in C-shaped rings. The trachea is lined with ciliated pseudostratified columnar epithelium. Cilia are slender finger-like organelles that beat in a rhythmic manner. The cilia work with mucus produced by goblet cells to clear unwanted particles and bacteria from the respiratory system. Together they form what is called the mucociliary elevator. This mechanism also extends to the nose and bronchi. The mucus traps the unwanted particles, and the constantly beating cilia push the substance up the respiratory system. The mucus eventually reaches the top of the throat where it can be discarded. In an ideal world, the air we breathe would be clear and free of any dangerous contaminants. Unfortunately, we breathe in smoke and dust particles created by pollution every single day. Viruses and bacteria are also inhaled, threatening our immune system and jeopardizing our health. So this mucociliary elevator is essential in preventing infection and disease. As we continue to breathe, air moves through the trachea and into the lungs. The trachea branches into the left and right bronchi. The bronchi continue to branch, forming bronchioles. The terminal bronchioles each end with a cluster of small air sacs called alveoli. Alveoli are crucial in the exchange of oxygen and carbon dioxide in the respiratory system. They are covered by very thin walls and are surrounded by an intricate capillary system. Capillaries are small blood vessels. The gas exchange takes place between the thin walls of the alveoli and the thin walls of the capillaries through simple diffusion. The concentration of oxygen in the alveoli is higher than the concentration in the red blood cells, so the oxygen molecules easily diffuse into the blood. Red blood cells contain an iron-rich protein called hemoglobin, which has a high affinity for oxygen, again making it easier for the transfer to take place. Carbon dioxide is a waste byproduct of cellular respiration which takes place in all cells. As the levels of CO2 build up in the cells, it again makes it easier for it to diffuse from high concentration in the red blood cells to lower concentration in the alveoli. As we exhale, we dispose of this potentially hazardous byproduct. And that's how we breathe. Pretty incredible, huh? Next week, we'll learn about the circulatory system, and you'll discover just how the oxygen acquired through the respiratory system gets distributed throughout the body through the blood. Stay tuned!